So continuing right on the last section, the main idea is still the y-intercept, that's the starting value, that's where we start at. Vertex is either the maximum or minimum. Got to pay attention to x is the when or where, y would be the actual value of the maximum or minimum. And the x-intercept is usually the ending value. So we're going to kind of take the similar look going through these. So Sarah kicked a ball in the air. The function f models the height of the ball as a function of time after Sarah kicked it. So here, this would be like her starting height. We'll read through the statements right now, but basically you have her starting height right here. That's the y-intercept. That's why I know that's the starting height. This would be the maximum. It's the vertex. And the max would be 14, but it occurs at about we'll just say 7 seconds. And then it hits the ground at about almost 3.5 seconds. We'll just say 3.4 seconds. So this is all I can come up with just looking at this. So let's look at these statements. So Sarah kicked the ball from a height of about 1 meter. So that makes sense. Let's just make sure we're meters, which we are. So that makes sense. About 1, our starting point is 1. Our y-intercept is 1. So yeah, and we got to choose all that applies. So that's 1 so far. We still got to read the rest of them. Gotta love these problems. And so Sarah kicked the ball from about a height of 14 meters. That would be up here if the y-intercept was at 14. No, the maximum is at 14. No, she kicks it up into the air. It reaches 14 meters. At its highest point, the ball was about 1.75 meters above the ground. No, the 1.75 represents the seconds. It occurs at that many seconds, but the actual maximum height was 14. So the highest point, we'd want this to be 14. Well, if you look at D, it says that at the highest point, the ball was about 14 meters. So that one checks off. So that's how you got to do these assignments. You just read through it. Let's look at this one. Looking at this graph, so we have mosquitoes as the y value. So the more rainfall, the more mosquitoes. But then eventually there's so much rainfall, you can see the mosquitoes start coming down if we get too much rainfall. So more rainfall relates to more mosquitoes as long as the rainfall is less than 2 centimeters. So here's rainfall. Rainfall's right here. So if it's less than 2 centimeters, that's talking about this segment over here. So does more rainfall, so as we increase our rainfall, are we getting more mosquitoes? And that answer is yes. As we increase our rainfall, our mosquitoes go up as long as we have less than 2, because after 2, we start to go down again. Look at this. More rainfall relates to more mosquitoes as long as the rainfall is more than 2. Well, if you look at more than 2, that's this section here. As we increase our rain, as our x values are going up and up, as we increase that rain, you can see our mosquitoes is actually going down. So that one would be false. So this one's good. This one's not. When there's no rainfall, that would be right here, because here's rainfall, that's axis. So when rainfall is 0 right here, there are about 1 million mosquitoes. No, that's if we had a y-intercept, if we started right there. But we're not. At no rainfall, there's no mosquitoes. When there's no rainfall, there's about 2 million mosquitoes. Now that's talking about up here. And no, that's not the case. We have no mosquitoes. Once again, no mosquitoes if there's no rainfall. All right, what about this? So we have profit and app price. So if we don't charge anything for the app, it costs money to make it. That makes sense, right? You have to pay for labor and stuff. So we're starting at a negative y-intercept. Excuse me. If the company doesn't charge for the app, they make $0. Now that would be the case if it was right here. That's not the case. If they charge $0, they would actually lose money. They would lose $10 million. If the company doesn't charge for the app, they lose about $10 million. Well, yeah, that's what we were just saying right now. Our starting amount right here, if we charge nothing, then we're right here at negative 10. We're going to lose $10 million. To make the greatest profit, the company should charge $7. So we see the maximums right here. The maximum profit is close to 40. But what price does that come at? $7. So yeah, at $7, they'll maximize their profit. And then obviously, if you charge more than $7, no one's going to want to buy it. That's why you start losing your profit. So to make the greatest profit, the company should charge $40. No, it's that $40 million is the greatest profit, but the amount that they would charge, the price would be the 7. So that's what I was telling you, it matters on where it occurs at. So that's the idea of this assignment. I mean, there's another one here. Greater the width means always make smaller area. No, because look, as we increase our width here, it's actually the area is going up. Greater width relates to smaller area as long as the width is less than 10. So let's look at less than 10. When the width is less than 10, no, look, the area is going up as we increase our width. As our width goes up, our area is going up because it increases. Notice area is the y value this time. So the first two are out. When there is no width, the area is 20. That would be if the area, that would be if we had a y-intercept right there. We don't have that y-intercept, so that one's out. Then last, when there's no width, the area is 0. That makes sense. And there's no width, look, right there, 0. Zeros are where it's going through the origin. So yeah, that one makes sense. So that's the idea of this assignment. Just take your time, carefully read this, maybe watch the video again as we go through that, or as I went through that and explained it for you.